Example number 4 of solving the following rational inequality. We have a rational expression on the left and another rational expression on the right. So first thing we need to do is subtract. We need to subtract this rational expression on the right so that we can have 0 on the right side of the inequality. Okay? So this is what I'm going to write. I will write x plus 5 over 1 minus x, which used to be only the only fraction that was on the left side. Now I will bring minus 3 minus x over x plus 3. Keep that symbol exactly the same. Greater, oops, see what happened? Greater than or equal to, and nothing on the right side, go ahead and put a 0. So here, we need to use your pre-algebra, well, not pre-algebra, I apologize, algebra skill. So, x plus 5 over 1 minus x. What do I need to multiply to the top and the bottom of this fraction? To come up with the common denominator, I will multiply the numerator and the denominator by x plus 3. X plus 3 over x plus 3. Done with the first one. Next one, let's go ahead and copy down what it used to be. It used to be just 3 minus x. 3 minus x over x plus 3. Well, what must I multiply to the top and bottom of this one? Well, that is 1 minus x. So let's multiply the top and the bottom by 1 minus x and 1 minus x. If I do that, the denominators are now exactly the same. Yay! Okay. Before I subtract them, I think I will go ahead and FOIL because this is going to be kind of confusing with the symbols. How about I FOIL the numerator? Numerators, okay, because we have two fractions right now. I know I usually combine them immediately because distributive property is not confusing, but I'm gonna go ahead and distribute first or multiply first, and then I will subtract those two trinomials. Okay, first of all, x times x is x squared. Next I will have plus 3x, but guys, I don't want to use another line, so can I just go ahead and say 3x here? And then the next one is plus 5x. So I'll combine them and write that as plus 8x. Okay, and then the last number, 5 times 3 will give me plus 15. Okay, so I'm done with the first fraction, the numerator. And let's go on to the next one. 1 times 3 is 3. 1 times negative x is negative x, but I wrote that above because I think I'm going to have another middle term. And negative x times 3 is negative 3x. So they will add up to negative 4x. And lastly, negative x times negative x is positive x squared. So I am subtracting that blue trinomial from this red trinomial, and that is going to be the numerator. Okay, we need to make sure that everything is correct, no sign mistake or anything. So let's go ahead and combine those two polynomials by subtracting very carefully. Okay, this is what I'm doing. So the numerator will be, look, x squared plus 8x plus 15. But if I distribute the negative sign to that blue trinomial, it's gonna come out as, watch very carefully, negative 3 first, right? And what's next? Negative times negative 4x is positive 4x. And lastly, negative times positive, that's going to change to negative because we were subtracting. So that's why I wanted to FOIL all these first, because the sign could have been very confusing. I'm almost done. The denominator is 1 over x, 1 minus x times x plus 3. All right, at some point I was so busy solving these or simplifying these rationals, I forgot to bring down that greater than or equal to 0. So let me just put those back. And now I am combining some like terms over here. So do you see any like terms? I see there is x squared and negative x squared. Oh, look at that. They will now cancel out. Cancel, cancel. What's next? Do I have any other? I see there is a positive 8x and there is positive 4x. So they will add up to 12x. And if I combine 15 and minus 3, this is going to give me plus 12, isn't it? All over 1 minus x times x plus 3. And this is, we're trying to still solve when that is greater than 0. I'm looking at the numerator. I can factor out the 12 in front and have x plus 1 in the numerator, in the parenthesis. And the bottom is still the same. Now we're ready to talk. Oh, goodness, that was a long work. But I know you guys have that rational expression skill, so this was okay. Now let's talk about solving this inequality. So what is a 0 of the numerator? 0 of the numerator. 0 of numerator is x equals negative 1. Where did I get that from? Well, if you plug in negative 1 in there, wouldn't that give you a 0? Yep. What kind of circle will you plot? Numerator can be open or closed. And because the symbol says greater than or equal to, I'm going to go ahead and plot a closed circle. It has to be a closed circle at negative 1. Let's go find the zeros of, I'm going to say zeros of denominator because I see two factors there. Zeros of denominator. What are they? The first one is x equals positive 1. Why? Because if I plug in 1 in there, 1 minus 1 will give us 0, right? The next 0 comes from the factor x plus 3. So that will be x equals negative 3. But remember, both of these, both x equals 1 and negative 3 must be what kind of circle? Open circle. Why? Because these are the zeros of the denominators. They can never be a closed circle. So I'm ready to go and number them, graph them, and I'll go ahead and number them on this next page, okay? So smallest number is negative 3. Next smallest number is negative 1. And the biggest number is 1. If I make sure to use the correct circle types, negative 1 will get a closed circle. I have to be very careful. 1 will be an open circle and negative 3 will also be an open circle. I need to plug in numbers now, okay? But I'm going to plug it into this function. So I will go ahead and copy this, you guys, and I will bring it down here. This is where I'm going to plug in. Come on. This is where I'm going to plug in. So starting with the one interval that is all the way on the left, I will plug in x equals, what's the number that is in that interval? Smaller than negative 3. I can think of negative 4. I will plug in negative 4 into that function now, or inequality, not a function yet. Negative 4. And you know, guys, I'm doing this without a graphing or scientific calculator. If you have it, use it. You don't need it, though. Just going to take longer time. 1 minus negative 4 will give me 1 plus 4. And the other factor is negative 4 plus 3. Okay. Let's simplify to see if this is true. I'll have 12 times negative 3. The bottom of the fraction is 5 times negative 1. So I will get negative 36 over negative 5 greater than or equal to 0. And negative divided by negative is indeed positive. So is positive number greater than or equal to 0? Yes, that is so true. Yay, we found the first answer interval. So I'm going to go up to my number line and I will go ahead and draw a line, or yes, a line going to the negative infinity from negative 3. Okay, so we're good. Let's go check out the middle interval. the middle number, a number that lives in between -3 and -1. What's in between -3 and -1? I'm going to use -2. Okay, I will plug in x equals -2 here. If I do that, I will get 12 times -2 plus 1. And as you can see, I'm plugging it into the simplified function that I rewrote. 1 plus 2, because it's going to be 1 minus -2. That's why I wrote 1 plus 2. And -2 plus 3. Let's see if this is greater than or equal to 0. 12 times -1. 3 times +1, isn't that? Oh my goodness. So this is going to give us -12 divided by +3, which means -4 is greater than or equal to 0. Oh, is -4 bigger than 0? No, this is false. Because this is false, this interval where we graphed x equals -2 from is not an answer. So I'm not going to highlight it, okay? So let's go on. We have 2 more intervals to test and we will be done with this problem too. Okay, how about in between -1 and +1? Can I plug in x equals 0? I'll do that because 0 is in between -1 and +1. So let me plug in x equals 0. Hopefully that's easier. The denominator is 1 minus 0, 1 minus 0, and 0 plus 3. And we want to see if that is greater than or equal to 0. So let me zoom into this green piece and let's simplify this. That is 12 times 1 on the numerator. And the denominator is 1 minus 0 will give us +1. Okay, hold on. +1. And 0 plus 3 is just +3. So we get 12 divided by 3 is greater than or equal to 0. And 4 is greater than or equal to 0. So this is true. Awesome. We found one interval where this number is from. X equals 0 is from. That interval is going to be the answer interval. So let me go back to my number line, and I will highlight that. Whoopsie, that's too fast. So where the 0 came from, I will connect these 2 dots. Because anything in between -1 and 1, including that 0 that we just tested, are going to satisfy this inequality. Which means if you plug it into this inequality, it's going to come out to be greater than or equal to 0. Or greater than 0 is just fine. All right, let's do the very last interval. Let me go ahead and make this a little bit smaller. So what number can we plug in that is to the right side of 1? I'm thinking 2. So lastly, let me plug in x equals 2. So that is 12 times 2 plus 1 over 1 minus 2 times 2 plus 3. Is that greater than or equal to 0? That's what we need to figure out. That is 12 times 3 over -1 times +5. Is that greater than or equal to 0? Let's see. That is 36 for the numerator. Denominator is -5. Well, if the denominator is negative, the numerator was positive, this is a negative number. A negative number is not greater than or equal to 0. So I'll say this is false. So the last interval is not this solution. I do not have to underline that. I got all my answers marked on my number line. Let us go ahead and write the final solution then, okay? Let me change that to black color pen. So here's the solution or the answer interval solving this inequality in interval notation. The one all the way on the left is going to negative infinity, as you can see. So I will say parenthesis, negative infinity, comma, the number is negative 3. But after negative 3, you notice it's an open circle. So we will need to draw a parenthesis. Union. Now the next dumbbell looking interval is from negative 1, who has a closed circle. So I'll draw a bracket, square bracket, negative 1, comma. It's going all the way to positive 1, right? All the way to positive 1. And I will close the parenthesis because that 1 is an open circle. So this is how you can solve this rational inequality. I'm not going to say that this is easy. This takes some, this takes some work, as you can see. But you have spring break next week. You guys can try this. Oh, look. Ooh. I just learned that I can play with my writing that way. Okay. So, but that's enough for solving rational inequalities. You just watched 4 videos on solving rational inequalities. You're ready to jump into Alex's homework and try them on your own now.